Connecting graphs to equations, part 2. Today you'll learn how to find the slope and vertical intercept of a line with an equation of ax plus by equals c. You'll also learn how to take an equation in standard form and rearrange it to form an equivalent slope-intercept form. The slope-intercept form of a line is y equals mx plus b. M represents the slope, and b represents the y-intercept of the line. If we're given a real-world situation, the slope will represent how the situation increases or decreases, and the y-intercept will represent the initial value of our situation. We can convert any equation in standard form to slope-intercept form by solving the equation for y. Let's look at an example. Let's analyze the equation of May's bus pass situation. She starts with a balance of $40 and spends $2.50 per school day. So we know our equation will be in y equals mx plus b form, and m represents how the situation increases or decreases. So in the story, it tells us that she spends $2.50 per school day. So since she's taking the $2.50 from her original balance, she's subtracting it. So we'll turn m into negative 2.50. And then we know that b represents the initial value. And the story tells us that she starts with a balance of $40. So we can replace b with 40. And now we have an equation for this situation. Here's another example. And the graph below represents a equals negative 20t plus 450, which describes the relationship between gallons of water in a tank and time in minutes. So let's start by looking at the equation they gave us, because we're used to seeing variables y and x, where y is the dependent variable and x is the independent variable. It's okay to switch these variables. They don't always have to be y and x. As long as they're in the same form and the variables match the dependent and independent, then you could switch the variables to any letter you want. So we can still assume that the negative 20 will be the slope and 450 will be the y-intercept. So where on the graph can you see the 450 from the equation? So if we look at our graph, we can see 450 on the y-intercept, and that's where it starts. So we can say that 450 is the y-intercept looking at this graph. Where on the graph can we see the negative 20 from the equation? So negative 20 is in front of the variable, so it should represent our slope. So let's just confirm that negative 20 is shown as the slope on this graph. So we want to start with any 2 points on this line. We should pick points that are intersected pretty nicely so we don't have to work with fractions of a number. So here's one possible point A, and here's another at point B. And again, we could have picked any points. Those are just two that stuck out that cross pretty nicely. So we know that slope is the y change over the x change. So let's look how we can get from point A to point B and see the y value change. So if we start from B and we go up to A, we started at 50 on our y-axis and ended at 250. So that means we must have gone up 200 units. So we'll make the y change into 200. Now let's look at how the x changes. So if we go over to A, it shows that we started at 20 on the x-axis and ended at 10. So we went backwards 10 units, or 10 minutes in this case. Since we went backwards, we'll make the x change a negative 10. So now we can simplify and divide, and we'll get a slope of negative 20. So now that matches the question, and we can say for sure that negative 20 is the slope. So what do these numbers mean in this situation? So 450 is the y-intercept, and that will tell us the amount of gallons that started in the tank. And negative 20, which is our slope, shows the rate the water decreased per minute. Here's one more example. The graph below represents 4x plus 2y equals 10. It describes the relationship between pounds of almonds and figs and the dollar amount Claire spent on them. Suppose a classmate says, "I'm not sure that the equation is correct because I don't see the 4, 2, or 10 on the graph." How would you show your classmate that the graph is correct? So the equation they gave us is in standard form, and sometimes those numbers aren't as clear on the graph as when given in slope-intercept form. So let's take this equation and we'll put it in slope-intercept form to see if we can find those numbers on the graph. So to put this in slope-intercept form, we're going to solve for y. So let's start by subtracting 4x from both sides. If we do that, we'll end up with 2y equals 10 minus 4x. And now we'll divide everything by 2 to get y by itself. So we end up with y equals 5 minus 2x. And just to put it in slope-intercept form, we'll switch the order and we'll put y equals negative 2x plus 5. So it didn't change the values, it just looks how we like to see slope-intercept form. So now we have our equation and we can see if we can find these numbers on the graph instead. So if we look at the y-intercept of 5, we can confirm that it is the y-intercept. And if we look at a slope of negative 2, it shows that it goes down negative 2 units and over 1. So now we can see these numbers on the graph and we can convince our classmate that we just needed to rearrange our formula. Okay, let's put all this together in practice. So let's find the slope and y-intercept for each equation below. So here's a total of 4 problems, and if you look, they're all in standard form. So we'll just put these in slope-intercept form, that way we can pull out the slope and the y-intercept. So for the first example, we want to solve for y, so let's start by adding 4x to both sides. And we'll get 3y is equal to 3 plus 4x. And then our last step is to divide everything by 3 so that y is by itself. So we'll get y is equal to 1 plus 4/3 x. And then we'll just switch the order so it looks like what we're used to. So now we can clearly see that m is 4/3 and b is 1. Now let's do the next example. So we'll start by subtracting 12x from both sides. That will give us negative 4y is equal to 8 minus 12x. And then we'll divide everything by negative 4, giving us y is equal to negative 2 plus 3x. So we'll switch the order, and now we can see that the slope is 3 and the y-intercept is negative 2. Okay, for the third example, we'll subtract the entire x term, so we'll subtract 8x from both sides like usual, and we'll get 2y is equal to 16 minus 8x. We'll divide everything by 2, giving us y equal 8 minus 4x. We'll switch the order around so we can clearly see that m is negative 4 and b is 8. Okay, let's do the last one. And we see a fraction, so this might be a little different, but we'll still get through it together. Okay, let's add x to both sides of the equation. So we get 1/3 y is equal to 1/3 plus x. So usually at this step, we'll divide by the coefficient of y to get it by itself. But when we have a fraction, we do things a little differently. So we want to multiply 1/3 by the reciprocal. So the reciprocal is just the upside down version. So we're going to make 1/3 into 3 over 1. So we just switch the order of the numbers. And if we simplify 3 over 1, this would just be 3. Oops, sorry. Because 3 divided by 1 is 3. So we're going to multiply the entire equation by that reciprocal of 3. So if we multiply everything by 3, we'll get that y is equal to 1 plus 3x. And we'll switch the order, and we can see that m is 3 and b is 1. All right, let's summarize everything that we've learned about connecting graphs to equations. Linear equations can be written in different forms. Each form has its advantages and disadvantages. In a real-world situation, the slope tells us the rate of increase or decrease, and the y-intercept tells us the initial value.